want to make...
DD mega doo-doo.
I'm losing my voice. I want to make a video just looking at what I've learned exploring the Mandelbrot. It's just Mandelbrot.
Benoit, Mandelbrot.
Okay. First thing I'm going to do is I'm going to take you to my link tree, to my blog. Is there not like a menu? Okay, scroll down. Now, here we go. Beautiful, smooth Mandelbrot plots. Have you ever seen a show with... Okay, I should do a bit of an introduction about how you produce these things. And for that, we're going to need C++. Mandelbrot. Right. Find Mandelbrot. It's a function with a maximum number of iterations, and it starts with I equals 0. And this one has a gradient scale and a color length, but that's not important right now.
A hospital? What is it?
It's a big building with patients, but that's not important right now.
You set the real and imaginary parts to 0, and then you go around a loop. Right. So in the loop, we're going to square a complex number. So we start with CR and CI. We send into this function a complex number, CRCI. Then we set another complex number, ZRZI, to 0, 0. We square that number and we add CRCI to it. And then we square it again and we add CRCI to it. And then we square it again and we add CRCI. And we keep doing that until either we reach the maximum number of iterations or the magnitude of the number exceeds real squared plus imaginary squared has to be less than 4, otherwise it breaks out of the while loop. And then this is where the magic happens. Some smoothing takes place, and then the result is mapped onto like a color spectrum that's previously defined. I learned about how to do the color spectrum from, where was it?
I got them. 1.9 trillion.
Here? Yeah, no, yes. Okay, so somebody asked the question about which color gradient is used to color the Mandelbrot in Wikipedia. And you'll see in my blog post, I did experiment with this color gradient. And what you do is you use 16 colors and you just keep looping around those colors using the remainder. So you just divide by 16 and keep the remainder. And that gives you an answer between 0 and 15. And then you use that as a pointer to 16 colors. But then this dude comes along and says some stuff that didn't make any sense to me. But look, so what you should imagine is, so they say here, the gradient is probably from ultrafractal. It is defined by 5 control points. And you have to imagine a spectrum. And I think I ended up with 2048 different positions. So you could think of, like, imagine it as an array from 0 to 2047. And the color at point 0 would be this color over here. And the color at point 2047 would be this one over here. C++ arrays start at 0. So what you need to do is create this spectrum. So you need an array, and at each point in that array, it gives you a red, a green, and a blue number. And as you can see here, there are certain positions along the way that are defined. And although this person is saying you should use cubic interpolation, I just joined all the points up with straight lines. And I think whether this one or this one looks better is pretty subjective, to be honest. Yeah, I think the second one probably does look better, but it's for a later phase. Okay, so what I ended up doing in my code, static red 2048, I've marked out certain points along the array, and at those points I've set the red numbers to 0 or 32 or 237 or 255 or 0 or 0. And you can see these here. Look at the red, 0, 32, 237, 255, 0. And then, in a very clunky way, horribly horrible way, I've joined those with straight lines, and then I've done the same thing for green and the same thing for blue, and then those just sit there as static red, green, blue spectra. And then out of my Mandelbrot calculation, I produce a number between 0 and 2047. And then what happens? Right. Find Mandelbrot brings back a value n. And then R gets mapped to red n, G gets mapped to green n, and B gets mapped to blue n. Here we go. Okay, so this is what it looks like from the outside. Then it zooms in a little bit. A bit more. It starts to look quite good. That's the last one. Yeah, so I was pretty happy with the way they looked. There's a bit more work to do, and the main thing that I've got left to do is to install libjpeg, which I'm having real trouble because I'm just trying to figure this stuff out myself. And installing packages is where I run into problems with Python as well, getting everything to kind of work. The coding bit, probably not the most sophisticated code, but it works. I can do the programming bit, but it's just getting this thing. It's exporting PPM files at the moment, and you know, ideally I'd like to export thousands of JPEGs and then just use FFmpeg to animate them so that you can actually see a proper zoom. Please consider putting a like on my video, and if you want to see more stuff like this and like all the other random stuff on my YouTube channel, please subscribe. Thanks a lot.